Good morning, students. I think you can see my screen now. So today we are going to discuss about, again, a multiple linear regression models. But if you just think about the models that we have fitted so far, in all the models, we were using the quantitative variables. For an example, if we want to see the relationship between, let's say, the advertising expenditure and sales, both are quantitative. So if you want to fit a regression model between height and weight, again, both are quantitative. So, so far in the models that we have fitted, we have been using quantitative variables. But when it comes to regression, it's not a must that you have to use quantitative variables. You can use qualitative variables as well, because there are situations that we can see there is an impact from the qualitative variables towards the response variable. So in such situations, we have to use qualitative variables also to fit our models. So today we are going to talk about how to fit your model using a qualitative variable. Now, in this case, if you look at this data set, this is the example data set that we are going to use. So here you have 4 variables. So if you look at the first column, that is denoted as S, that is the salary. Now, in this case here, we are going to find the relationship between a sample of employees about their salary and some other determinant. So here we have used their experience and their education level and their management position. So capital S, that is denoting the salary, and capital X is for the experience. So experience is recorded using, it's a quantitative variable, the number of years that they have experience in this particular field. And if you come to this variable, capital E, that is their education level. So in this case, for the education level, they have 3 stages. That is, if they have completed high school, they have denoted it as 1. And if they have completed a bachelor's degree, they have denoted that by 2. And if they have completed an advanced degree, they have denoted that using number 3. So 1 for the high school diploma, 2 for the bachelor's degree, and 3 for the advanced degree. So if you take M, so M is the management position that they are in the company. So that is, if this person is holding management responsibility, that is coded as 1. If this person is not in the management level, that is denoted as 0. So this is our data set. Now we want to check whether there is any effect or whether there is any relationship between this salary and the number of years that they have experience in and their educational level, and also with the management position that they are holding. So in this case, if you check, of course, we can see our response variable, that is salary. It is a quantitative variable. Now, in this case, actually, when you are fitting regression models, when you're modeling your response variable, that can also be a qualitative variable. But when it comes to multiple linear regression, we are not talking about the cases where your response variable is a qualitative variable. We are always dealing with the situations where your response variable is a quantitative variable. But there are situations when you are doing your final year research, you have to fit regression models where your response variable is also a qualitative variable. So in that case, you can use logistic regression model, multinomial model, and these models we'll be talking later in another course. So in this case, we are talking about when it comes to multiple linear regression, your response variable is, in this case, it's always quantitative. So we can see here our response variable is salary. So it is a quantitative variable. And when it comes to this variable, capital X, years of experience they have, again, that is a quantitative variable. So the problem is, problem we are having is with these two variables, where the education level and their management position, they are not quantitative variables, they are qualitative variables. So now we want to fit a regression model using these 4 variables. So in this case, when you have qualitative variables in your data set, and when you're going to fit a multiple linear regression model, then we have to use a coding. Right now, in this case, if you look at the variable capital M, the management position, in that case, we have only 2 categories. If this person is holding a management position, it is coded as 1, otherwise it's 0. So if your categorical variable is having only 2 options, only 2 categories, then we do not have to code. We are not going for coding if it's having only 2 categories. But if you look at this variable, the educational level, in that case, we have 3 categories. 1 is for high school diploma, 2 is for the bachelor's degree, 3 is for the advanced degree. So in that case, if you have more than 2 categories, we have to recode your variable. So to do that, we have to use a dummy variable in regression. So when you're using the dummy variable, first we have to check how many categories we have. Now in this case, for the educational level, you have 3 categories. So if you have 3 categories, we are going to use 2 dummy variables in order to describe these 3 categories. So the number of dummy variables that you are going to use in your regression model, that is equal to the number of categories you have minus 1. You have to subtract 1 from the number of categories you have in your qualitative variable, and you have to use that number of dummy variables in order to code that variable. So in this case, for an example, now since we have 3 categories, we are going to use 2 dummy variables to code this educational level. So in that case, what we are going to do is, we are going to use 2 dummy variables as E1 and E2. So you can see, we are going to use E1 and E2. So how we are going to code this is, now for an example, this can be different from person to person. In this case, for an example, just imagine if you are taking the ith person in the sample. So EI1 means if this ith person has completed a high school diploma, we are going to code capital E as 1. Otherwise, it's as 0. And let's say EI2, that is if the ith person has completed the bachelor's level degree, then we are going to code EI2 as 1, otherwise 0. So if you take our 2 dummy variables, E1 and E2, we can see we are going to code E1 as 1 when this person has completed high school diploma. So if you take the high school diploma, only E1 is 1, we can see, otherwise it's 0. E2 should be 0. And if it's come to bachelor's level degree, we can see we are taking E2 as 1, otherwise 0. So E2 is 1, otherwise 0. So the remaining option, the remaining category is the advanced degree. So for the advanced degree, we have to take both dummy variables as 0. So in this case, we can see now we have three different categories using these two dummy variables. When E1 equal to 1 and E2 equal to 0, it's talking about the high school diploma. And when E1 0, E2 1, they are talking about the bachelor's level degree. And if both dummy variables are equal to 0, they are talking about the advanced level degree. So in this case, actually, what happens here is, now when you take the advanced level degree, since the both dummy variables are equal to 0, when we fit the model, when we compare the coefficients of the model, you will see we have to always take the baseline as the advanced level degree. That is, we are getting the coefficient with compared to the advanced level degree. Since these two coefficients, these two dummy variables are equal to 0. අපි dummy variables දෙකම බිඳුව වෙන variable එකට අදාළව තමයි coefficients අපිට එන්නේ. එයා තමයි baseline variable එක. එතකොට අපිට එයාට අදාළව තමයි අනිත් variables ගැන කතා කරන්නේ. So we have to always compare the coefficients of the other variables with compared to this baseline model. Now you can question, now why I take advanced level degree as 0? So that is not a must. If you want, you can take the advanced level. When you take the advanced degree level, you can take E1 as 1, E2 as 0, and you can take the high school diploma E1 as 0, E2 as 1, and for the bachelor's level, you can take both as 0. So that is something up to you. So you can fix that as you like. You can just jumble this combination and fix it. So you can take this level, that is where you can equal both dummy variables to 0 when you're talking about the baseline level. So if you want to compare all your findings with compared to the high school diploma, it's better to take both E1 and E2 equal to 0 for the high school diploma. So that is up to you. So in this case, we actually, if you really want, now we are using only two dummy variables, but if you really want, we can go for more than two dummy variables as well. But it's not a rule, but in general practice, what we do is we are checking how many categories we have in our qualitative variable, and we take we subtract 1 from the number of categories, and we take the remaining number, and we are taking dummy variables which are equal to that number and use them as a practice. But if you really want, you can go for more than this as well. It's not a must. Now, when it comes to our regression model, now let's check. So our response variable is now capital S, salary. So when it comes to our regression model, we need to have an intercept. So our intercept is denoted by beta naught. We have an intercept that is denoted by beta naught. And then we have our the quantitative variable experience, which is denoted by capital X. So we can take its coefficient as beta 1. And then we have two dummy variables to represent the educational level, that is E1 and E2. Let's take its coefficients as gamma 1 and gamma 2. And then we have the management position. Since it has only two categories, we are going to take that variable as it is. So we are going to take that variable and let's take its coefficient as delta 1. And we have the error. So this is the model that we are going to fit using our data set when it comes to multiple regression. So in your exam, if I give you a situation like this, and if I ask you to write the initial model that you are going to fit using this data set, you have to write down this model, And in that case, you have to explain what are these E1 and E2, the dummy variables. You can show these combinations as well. So you have to write down your model. Now let's see what's happening here. Now we know E1 is a dummy variable, E2 is a dummy variable, and capital M, again, it's a qualitative variable. We have two categories, 1 or 0. So in this case, let's see what's happening here. So when you take the educational qualification, we know we have actually 3 categories. We have 1, 2, and 3. So to represent that, we are using this E1 and E2 dummy variables. And when it comes to capital M, again, we have 2 categories. If this person is holding a management position, that is equal to 1. If the person is not holding a management position, it's equal to 0. So in this case, let's see. Now, imagine your educational qualification is equal to 1. That is, you are having a high school, you have completed a high school diploma. So in that case, if your educational qualification is equal to 1, then this particular person can hold a management position or not. So M can be equal to 0 or 1. So when it comes to educational level 1, M can be equal to 0 or 1. So with E equal to 1, we can talk about when M equal to 0, as well as when E equal to 1, we can talk about a situation where M equal to 1. So it's similar for the other levels as well. When the educational level equal to 2, that is when you have completed a bachelor's degree, again, M can be equal to 0 or M can be equal to 1. And when you have completed advanced level degree, again, M can be equal to 0 and M can be equal to 1. So actually in this data set, we can see there are 6 different combinations. There are 6 different categories of people in this data set if you just have a look like this. So let's see what will happen in each case. Now, if you look at the first category of people, so their educational level is 1. That is, they have completed their high school diploma, and then they have their management position is equal to 0. So if you look at our data set, so if you have completed the high school here, in the coding, we have to set E1 as equal to 0, but E2 as equal, E1 as equal to 1 and E2 as equal to 0. So if you look at our model, now in the model, we have beta naught, beta 1x, and E1 you have to equal to 1 if you have completed the high school diploma. So here you have gamma 1 then, gamma 1 times 1, that is gamma 1. And E2 is equal to 0. So gamma 2, E2, this part is, we can omit that part. And delta 1 times M, that here M value is also equal to 0. So this part also we can omit. So in the model, we have beta naught, beta 1x plus gamma 1 times the error term. So this is the model that you get. So since gamma 1 is a constant, we can write S equal to beta naught plus gamma 1 plus beta 1x plus the error term. So for the people who are in this category, the regression equation would look like this. And if you go to the second category, now the education level is the same. 1, that is they have completed a high school diploma, but when it comes to the management position, that is equal to 1. So if it is a high school diploma, we have to fix E1 as equal to 1, E2 as equal to 0, and here M is also 1. So if you go to the initial model, now beta naught is there, beta 1 x1 is there, and E1 is 1. So from this part, we have gamma 1 plus E2 is 0, so we can omit this part. And in this case, m is 1. So we have delta 1 times 1, that is delta 1 plus the error. So that is when it comes to the model. Now we have beta naught plus delta 1 plus gamma 1 plus beta 1 x times the error term. So likewise, if you take this third combination, now your educational level is equal to 2. That is, you're having a bachelor's degree and m is equal to 0. So if you're having a bachelor's degree, E2 is equal to 1. So in the initial model, now you have to fit E2 as equal to 1. And here m is 0, m is equal to 0. So you have beta naught, beta 1x. Now E1 is equal to 0. So this part we can omit. Gamma 2 times E2 is 1. So here from this term we have gamma 2 plus delta 1 times m is 0. So this part we can omit. So in the initial model, you have S equal to beta naught plus gamma 2 plus beta 1 x plus epsilon. That is the error term. So likewise, for each and every category, we can see how your regression equation would look like. So you can just substitute the values in each category and check what happens to your regression equation. Okay, now I will show you how to fit this model using R. Right, so I'll show you how to fit the model using R. Now, first what I have done is I have copied my data set into an Excel file and I have saved that Excel file as a CSV file. So that one, you can also, first you can take your data set and then you can save your file as a CSV file. And then first you have to import your data set to R. So I will take, first I'm going to give a name to my data set. Let's say I'm going to give the name as, let's say, my data. So now you know the command to import a file to R, that is read.file. And here, let's say file.choose header equal true, because we want the values as the columns, the column names, and we want to separate all the values in columns. So this is the command that we are using. See what's wrong with. Yeah, so when you use this command, so you can choose your file from wherever the folder that you have saved. So my file is here. I have saved it as test3 as a CSV file. So I'm going to select my file. So now R will import your file, your data set. Now we can just have a look by calling the name of our data set. So in my case, it's my data. So you can see you have 46 values in my data, and all the 46 values have been imported to R. So if I just use this. See, if you just want to check the first 6 observations, you can use head and within brackets the name of your data set. In my case, the name I gave was my data. So I can see the column names and the variables I have imported. So you can see you have the salary, you have the educational level, you have the experience, and you have the management position. Everything is there. Now, if you just import this data set to R, and we know the codings and the functions that we can use to fit the regression models. So if you just fit a regression model with the use of these variables as it is, I will show you what happened. Now, if I, let's say fit 1, I'm going to give the name for the variable for the model as fit 1. So what I'm going to do is I will just take the LM function to fit the model. So what is my response variable? Capital S. And then I want to use capital X plus capital E plus capital M in my multiple linear regression model. And this data coming from my data set. So this is the command that we have been using in last few lectures to fit a regression model. So in this case, if I just call a summary of the regression model that I fit just now, summary within brackets, I have to give the name of my regression model. Now you will have an output like this. You can see here you have an intercept, here you have capital X variable, that is the number of years of experience these employees are having, and capital E as the education level, capital M is the management position. Now what has happened here is, now in our original data set, we have all numbers. So we are the people who know, even though for capital E and capital M, we have numbers, they do not have any numerical meaning. They are just codes. They are qualitative variable, but R have no idea about that. So when you just import your data set, and if you just use this LM function to fit a model, what R will do is they will take all the variables as quantitative variables and fit your model. So actually this output is wrong, because here they have considered capital E, the education level, and capital M, the management position, both as quantitative variables, and they have fitted the model. So that is a mistake. So first we have to tell R that in our data set, we have this capital E and capital M, where you have to treat these two variables as qualitative variables. So these are integer values you have, right? The numerical variables. So in that case, first you have to convert these numerical values to qualitative variables. So for that, what we are going to do is, now if you just take now my data, if you just take the capital E variable, if you just want to check the structure of this capital E variable, you can use the function str structure, and in my data set we are checking the variable capital E. So if you just call this function, you will see they have taken that as a integer variable, that is they are considering their numerical values. So we want to convert this into qualitative variables. So in that case, what you have to do is, now my first variable that I want to convert is capital E. So this capital E is coming from my data set. So you have to write my data with $mark capital E. So this one I have to convert into a qualitative variable. So for that we are using as.character function. So you can write as.character, and within brackets you have to give the variable. Now our variable is my data $mark capital E. So our variable is capital E. It's coming from my data frame. Now if you just check here, now when you check the structure of now capital E variable, they have converted that into a character. That is now their qualitative values. Same thing you can do with the capital M variable. So here I want to take the variable capital M and convert that into a character. So you can just check the structure of capital M as well. See, now it has been converted into a character. Now we have converted the two variables into qualitative variables. Now, before fitting the regression model, there is another thing that we have to do, because when it comes to the capital M variable, there you have only two categories. So no problem, we are not using dummy variables. You can use that variable as it is to fit the regression model. But there is a problem with this capital E variable, the educational level, because there you have three categories. So I told you, if you have more than two categories, we have to go for a dummy variable. So in R, you can ask R to code your variable using dummy variables. So you have to do that before you fit the regression model. So what you can do is you can use model.metrics function. This is an inbuilt function in R to code your categorical or the qualitative variable using dummies. So within brackets, you can give the $mark and capital E, and that is the variable that you have to code using dummies. First, not the $mark. So first you have to give the variable with this mark that you have to code using the dummy variables. And then you have to say the data set which this variable is coming. So in that case, data equal to, I have given the name as my data. So in this case, now I'm using my variable capital E, and I'm going to code this capital E variable using dummy variables. So this is the command that I'm going to use. So if you just want to check the codings, what you can do is you can just use this function, and you can store, let's give a name to this one. You can store all these values to a particular object. And then what you can do is you can just check the first few values with all the rows of this object. So that is, the object name is res, it's a matrix. And here, so you have to use the square brackets. And we are going to check the values. Here, now this is the coding that you have, that they have used. You can check this because actually when you check this one, what will happen is, now you can see they have used E2 and E3. That is, they have taken E1 as your base level. So for the E1 category, that is when the educational level is equal to 1. That is when these employees have completed a high school diploma. These E2 and E3, both dummy variables are equal to 0. So I told you, when you are fitting these dummy variables, that is subjective. You can take the value as it is. You can just jumble these combinations, and you can give the category names as you like. So that is subjective. So when you want to interpret these values, we have to check what R has taken. for their dummy categories. So in this case, we can see when R is coding this educational level variable, it has used E2, E3 as the dummies, and that is for E1 level, E2, E3 both are equal to 0. Now after that, I can fit the regression model. So I will give the name as fit2. So I can use the LM inbuilt function. So my response variable is capital S, and then I'm going to use capital X and capital E, capital M, and all these variables are coming from my data set. Now let's call the summary. Okay, so you can see now this is the correct output. You can see this output is different than the previous output. This output is different than the previous output. So if you look at this, we have the intercept, we have capital X variable, and we have E2, E3, and if you look at M, they have taken M1 here. That is, this coefficient is talking about the effect of the model when M is equal to 1. So this is the output that you get. And before I describe how to do the interpretations, I will show you now for the same model. If you want to take, now we know when you fit a particular regression model, we always tend to check the validity of the fitted model. So in last lecture also I told you, when you are going for the multiple regression, how to check. We can do the residual analysis. Apart from that, you can use the variable added plot, these graphical methods as well, to observe the accuracy of your model. So in this case also, let's say you want to the initial point that you can check the accuracy of your model is by obtaining the residual plot. So for that, we can use the same commands that we have been using in the simple linear regression. I told that one in the last lecture as well. So we are using the plot command. First, you have to give the name of your fitted model. So in my case, that is fit2. Then if you just put which equal to 1, that will give you the residual plot. Okay, so this is the residual plot that you can see for the fitted model. So I will now explain you how to interpret these values. Okay, so I have taken the model output to this. So this was the model output that we got from R. Now in this case, if you take capital X variable, that is the number of years that this years of experience that this employee is having. So if you look at the coefficient, that is 546. So this is a quantitative variable. So what's happening here is when the experience level is increasing by 1 year, on average, salary is increasing by 546 times. So with each additional year, the worth of this annual salary increment is 546. So that is the meaning of this coefficient. And when it comes to E2, E3, now they are coming from a qualitative variable. So in this case, as I told you, now your baseline is E1. That is, we have to do all the interpretations with compared to E1 level. So E1 is the higher diploma level. So you have to talk about these two coefficients with compared to higher diploma level. So in that case, if you take E3, you can see that is 2996.21, E2 3144.04. So that is, if you take the advanced degree is worth 2996.21 times than the high school diploma. And the bachelor's degree is denoted by 2. So that is 3144.04 times higher than the high school diploma. So in that case, you have to compare the two values like that. And when it comes to the management position, the coefficient is 6883.53. That is when management position is equal to 1. Right? So that is for a person who is holding a management position, the salary increment would be 6883.53 times higher than a person who is not holding a management position. So likewise, you can interpret these values using using this output. So in that case, if you further look at further down, if you can see the R squared value, the multiple R squared value is 0.59568. That is, it's close to 0.957. That is the proportion of salary variation, which is explained by the model with the use of all these variables, that is equal to 95%. So the 95% of the variation of the salary is explained by these variables. So you can take the model outputs like this, and then you can interpret your results. And if you look at the residual plot that we obtain, we discuss when we obtain the residual plot, if the residuals are distributed in a constant band, that is, your model is good. So you have constant variance. So the model is not violating the assumptions. But in this case, you can see, if you observe the residual plot, there are distinct categories in this residual plot. See, now in this case, it's not distributed randomly in a constant band. So you can see the residuals are clustered into several categories. So this kind of situations can be seen when we have qualitative variables. That is, when we have qualitative variables, we are using dummy variables in order to talk about its effect. But in this particular example also, you saw when we use the two dummy variables for the educational level variable, in that case, actually there are 6 categories, because when education level is equal to 1, capital M can be equal to 1 or 0. When education level is equal to 2, capital M is equal to 0 and 1. So likewise, actually in the data set, there are 6 different combinations. So maybe the number of dummy variables that we have been using, we use 2, it's not enough to describe the variation of the data. So that's why there are clusters in this residual plot. So what we can do is, if you observe something like this, we can use dummy variables for these 6 categories and then come up with a new model and then observe the residual plot of that new model, and then you can clearly see the clustering. So in that case, if you can see the clusters, so that is the variation of the model is not clearly explained by the use of the dummy variables. So that will imply we have to go for interactions as well. So there we have to include the interaction terms into the model. So we'll be talking about that later. So anyway, when you observe the residual plot, it will give you a hint whether you have to use interactions or you have to use some other dummy variables in order to fit the model accurately. But when you observe the residual plot, if you can see all the residuals have been distributed in a constant band nicely, then you can check the other assumptions of the model and you can use the model for prediction. So this is how we use the qualitative variables in order to fit a multiple linear regression model. Okay, with that, do you have any questions up to this point? If you have any question, you can raise it now. Okay, we have one question. We'll see. When testing hypothesis using ANOVA table, we reject the H node if FCal is greater than F table. Yes. Could you please explain how to take that critical region when H node reduce model is adequate? Yeah. So this is coming from the extra sum of squares. So when you are testing the extra sum of squares, as you have stated, your H naught is the reduced model is the good fit and H1 is the full model is the best one. So what you have to do is first you have to check. First you have to calculate that extra sum of square value. I hope you can remember how to calculate. You have to take the full model, you have to take the reduced model, and then you have to take the ANOVA table of both models. And then if you are taking the full model, we know in the full model, the regression sum of squares is a high value. And when it comes to the reduced model, regression sum of square is a low value. So you can take the difference between the regression sum of square and the regression sum of square of the full model and the reduced model. Or you can do the same thing using the error sum of squares, because when it comes to the full model, error sum of square is a low value. When it comes to the reduced model, it's a high value. So you can take the difference between the error sum of squares of the two models. And then what you have to do, you have to divide that by the respective degrees of freedom, and then that you have to divide by the error sum of square of the full model divided by its degrees of freedom, then you can obtain the F value. අපි full model එකට අදාළ ANOVA table එක ගන්නවා, reduced model එකට අදාළ ANOVA table එක ගන්නවා. ඒකේ අර extra sum of squares ඔයගොල්ලෝ calculate කරන්න ඕනේ. ඒතර අපි දන්නවා full model එකේ හැමතිස්සෙම SSR කියන එක වැඩි. මොකද regressors ගොඩක් තියෙනකොට variation එක වැඩි වෙනවා. එතකොට SSR එක වැඩි වෙනවා. හැබැයි error එක අඩු වෙනවා full model එකේ. reduced model එකේ error එක වැඩි, SSR එක අඩුයි. එතකොට ඔය දෙකේ කැමති එකක difference එක ගන්න එකම value එක එන්නේ. අපි example එකකුත් කරලා බලමු ඔයගොල්ලන්ට මතක ඇති. ඒතර ඉස්සෙල්ලාම මේ දෙකේ difference එක හොයාගන්න. ඊට පස්සේ ඒක අදාළ degrees of freedom එකෙන් බෙදන්න. So what is the degrees of freedom? That is the difference between the number of parameters in the full model and the reduced model. So I will just here, I will just type here and show you. Right. So in this case, let's say, so your H naught, let's say you have, just copy a model from this. Let's say our full model is this. Let's say our full model, our reduced model is this. And then our full model, let's say our full model is this. So we need to find which is the best model using extra sum of squares. So you have to obtain the ANOVA table using this reduced model and this full model. And then you have to take the difference of the sum of squares using the ANOVA table. That is, first, if you are using the regression, you can take the SSR of the full model minus SSR of the reduced model, and then this one you have to divide by the number of parameters in the full model minus the reduced model. So that you can, in the full model you have p plus 1 parameter, so that is in our case here you have beta naught, beta 1 and delta 1. So our case here 3 parameters minus in the reduced model beta naught and beta 1, only 2 parameters. So that is the degrees of freedom. So this whole thing you have to divide by this one, you have to divide by the sum of square error of the full model, and that you have to divide by its degrees of freedom. So the sum of squares errors degrees of freedom, you have to that is n minus p minus 1. Simple. N minus p minus 1. So from this you will obtain a f value. Making up it f value එකක් හම්බ වෙනවා. So this is the calculated f value in extra sum of squares. This is f cal. Now what you have to do? Now you have to check the table value from the f table. So when you're looking for the table value alpha, you can take it as 0.05, but in the f table you have to give the degrees of freedom of the numerator and the denominator. So in this case, in the numerator, degrees of freedom is this 3 minus 2, that is 1. So that is in the numerator's degrees of freedom you can give as 1, and the denominator's degrees of freedom here you have to give. So now let's imagine in this data set we have 46 points. So 46 minus in the full model you have to, here you have 2 variables. So p is equal to 2 minus 1. So in that case, 46 minus 2 minus 1, so that is 43. So the denominator's degrees of freedom is 43. Now you have to check this value from the F table. So when you check this value from the F table, if the calculated value is greater than this value, you can reject H naught. That is, you can say the full model is the best model. But if it is the other way around, you can use the reduced model. Is that clear? Any other questions? Okay, so I'm planning to upload 2 tutorials, and okay, there's another question. In here, we can take the extra sum of squares as difference between ESS of RM. Yes, the extra sum of squares you can take as the difference between the error sum of squares or difference between the regression sum of squares. You get the same answer. We did one example also. Yes, you can take the difference between the error sum of squares and do the calculations. No problem. So I'm planning to upload 2 tutorials today, tutorial 1 and 2. Tutorial 1, it's based on the simple linear regression, and I'll be uploading its answers as well. So you can do the tutorial by yourself and check with the answers. If you have any problem, when we'll be discussing tutorial 2, when you when we will be discussing tutorial 2, you can raise the questions, and if you have anything unclear, then you can say that ask the demonstrator to explain that point, so she will explain that. But tutorial 2, you have to do it and submit. I'll be taking marks from tutorial 2. So on Friday, we'll be discussing tutorial 2. So it's from the multiple linear regression. I will upload tutorial 2 today. So you have to do that and submit. So I'll be taking marks from that. And yes, so I think, you have any other questions? Okay, right. So then if you have no questions, I'm not going to take much time, because I know it's 6 o'clock in the morning. It's hard to concentrate a bit. So I can't even see y'all. So it's not like doing a physical lecture. So we'll stop from this point, so you can go through with the calculations and as well as the our outputs. Just do the codings by yourself. Then when you get familiar with the codes, it will be easy for you. So if we are going to have an online exam, I'm hoping to give questions from R as well. So you can do you can use your codings and take your outputs and submit them with the exam paper. So you have to be ready for that as well. Okay, so practice well. And if you have missed any lecture, go through the recordings. And if you have any question, please write to me. You can email me, or you can ask me during the lecture. Or if you feel comfortable with the demonstrator, you can ask from them as well. They are there to help you anytime. So then we'll stop from this point. Thank you so much and have a nice day.
Thank you, madam.
Thank you.